All right, continuing on. I'm going to do another example. Negative 5h to the fourth minus 15h cubed minus 10h squared. All right, so the first thing we're going to do is we're going to look for a GCF. And there definitely is. Remember I told you don't want leading negative, so we always want to take out that negative. And then what goes into 5, 15, and 10? 5 goes into all of them. And then what goes into h to the fourth, h to the third, and h squared? H squared goes into all of them, because you want the smallest of all of them. All right, so now I'm going to divide each one of those by my GCF. This is where that monomial division comes in. All right, and let's reduce. So now I get h squared, because 4 minus 2 is 2. Negative over negative is plus. 15 divided by 5 is 3. H, and then 3 minus 2 is 1. And then 10 divided by 5 is 2. And then those cancel. All right, and then from there, this is just a regular x squared and an x and a constant problem. So this is a equals 1. So blank times blank equals c. And blank plus blank equals b. Well, that's definitely 1 and 2. 1 times 2 is 2, and 1 plus 2 is 3. So now don't do that whole thing, split it up. It's always tempting, but don't with these. It's just h plus blank and h plus blank. And then don't forget your GCF. And that's your whole problem. Okay? Let me see here. I think that is all the ones that I want to go through. Okay. Just check and make sure that there's nothing tricky. Okay, yeah. So let's do one more. Okay. X to the 6th minus 3x cubed minus 10. Okay, so this is something new, because I'm going to look at it first and I'm going to think GCF. No. I mean 1 again, but no. All right. And then I'm going to go, okay, well, this isn't really quadratic, but there are 3 terms. If I'm following my, what do you call it? My factoring tree. Let me show you what I'm talking about. It's very difficult. It's on this arm. Let me go to the classroom, and I should probably go to our class. All right, and I'm going to look at the factoring flowchart. Okay. Nope, not that one. All types of factoring. There we go. All types of factoring flowchart. That one. There we go. All right, factoring, GCF. And then it has 3 terms, so it's an A equals 1 or A not equals 1 thing. Those are the only choices, because it's not 2 terms. It's not 4 or more terms, so it's 3 terms. So this is my only choices. Okay? All right, so let's go figure that out then. Well, so it's definitely A equal to 1. So I'm just going to go, all right, well, I'm going to just say this is C then, and this is B, and this is A, because that's all I know how to do. So blank times blank equals negative 10, and blank plus blank equals negative 3. 1 and 10 does not make 3. 2 and 5 does make 3, I think. So let's try that out. Yeah, I think I can do it. 2 and a negative 5 makes negative 3, because you want your bigger number to be negative if you want a negative number to add. And 2 times negative 5 is negative 10. So yeah, I got it. All right. And then you just do the x. So then normally it would go x plus 5, x plus 2, and x minus 5, right? Because it just goes x plus blank, x plus blank. However, these are x to the 6th and these are x to the 3rd. So when I multiply these out, what would each one of these need to be in order to make a 6? I want them each to be a 3. Why? Because 3 plus 3 is 6, and that gives you your middle one. Watch. So that's x to the 6th minus 5x cubed plus 2x cubed, which would be minus 3x cubed minus 10. See, so this is called quadratic in form. Grab your other color. This is the first time we've needed it in this. I don't. Okay. I think that's also black. And it's dead. My other color is going to be pencil. So I'm writing in pen. That's backwards. Okay, so grab your other color and go, all right, this is quadratic in form. Because this one times 2 divided by 2, not times 2. Sorry, divided by 2 equals x to the 3rd. See? And then this one's a constant still. So if the middle one of this one divided by 2 gives you this one, and then the last one is a constant, then it still works out, and you just use the middle guy for these. Okay? All right, that's it.